the very end of that thing, I hit a button and it took me to some other thing. So, but now we're back. We're going to do 12 and 13. Here we go. It says Pascal's triangle. To expand the binomial, be sure to simplify each term. 2x minus 3 to the fourth. So Pascal's triangle, we're going to go to the fourth row. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. Remember, we just add these numbers to get the next number here. 1, 4, 6, 4, 1. This is the fourth row. Why do we need fourth row? Because that's a fourth exponent. So those are the numbers we're going to use. 1, 4, 6, 4, 1. We now start with our first term, which is 2x. And we're going to take that to the fourth power right here. 2x to the fourth, 2x to the third, 2x squared, 2x to the first. And then this will be 2x to the 0, so it's not there. Then we start with negative 3, working our way back. Negative 3 to the fourth, negative 3 to the third, negative 3 squared, negative 3 to the 1, negative 3 to the 0. 2 to the fourth is 16. I'm not sure why it did that. I imagine because I'm kind of leaning on it. So let's go back to, okay, that didn't really do anything for us. 2 to the fourth is 16. Oh, okay, and I can't even write. Okay, let's come back. Can I write now? Nope. What if I come here? Okay, here we go. Sorry about that. 2 to the fourth is 16. X to the fourth times 1 is 16. X to the fourth. 2 to the third is 8. Negative 3 to the 1 is negative 3 times 4. And then we have x to the third. So 4 times 8 is 32 times negative 3 would be negative 94. X to the third. 2 squared is 4. So we get 6 times 4 times negative 3 squared, which is 9. 6 times 4 is 24. 9 times 24 is going to be 216. You might want to check my work on that, or, with the calculator. But I'm pretty sure that 9 times 24, I believe it's 216, I'm pretty sure. Now we get 2 to the 1, so we get 4 times 2 to the 1, which is 2. Negative 3 to the third is negative 27. So now we get 4 times 2, which is 8. 8 times negative 27, it's going to be 8, or negative, sorry. 6, bring it to 5. 8 times 2 is 16. 206, negative 216 again, x. And then we just get negative 3 to the fourth, which is 81. So there it is. And we're done. So this is starting with this basic function. Use transformations to graph this. Remember, IHOP overs. IHOP overs. If it's inside, in this case, inside the square root, it will affect it horizontally, opposite of what you think. So let's start working our way. So square root of x, we know looks something like this. The normal just square root of x. If we were to just graph square root of x, it's 0, 1, 1, 2, 3, 4, 2. It looks something like this. That's the normal graph. Now we're going to transform it. So the first thing we're going to do is we're going to work inside. So we have a plus 2. That means we're going to shift left 2. Why left? Because I do the opposite of what it says. So shift left 2. Every point gets shifted left 2. Okay, now it looks like that green one right there. Next thing now we're going to do is we're going to come outside and we have multiplication of a half. So all the y values are going to get cut in half. Well, 0 getting cut in half doesn't change, but 1 cut in half is a half. 2 cut in half is 1. So now it looks like this lower blue one right here. Looks like, yeah, that kind of stunk. Let me see if I can try a little better. Looks like that, okay? All right. Now the last thing we're going to do is we're going to shift down 3. Why are we shifting down 3? Well, that's because that's what this says right here. This says shift down 3. So this point's going down 1, 2, 3. This point's going down 1, 2, 3. And this point right here is going down 1, 2, 3. And there's our graph. So, and the original is on there. Okay. Okay, we're done.